Okay, so today I am going to be proving the identity that the hyperbolic tan ln x is equal to x squared minus 1 over x squared plus 1. Alright, in order to do this, there's a few things that we need to know. We need to know that hyperbolic sine of x is equal to e to the x minus e to the negative x over 2, and hyperbolic cosine of x is equal to e to the x plus e to the minus x over 2. These are just definitions or whatever you want to call it. But you only need to remember these ones. Because with these ones, the hyperbolic in the sense of this, in particular of this, is the same as just the regular trigonometric functions, right? So you know that tangent is sine over cosine. So similarly, hyperbolic tan of x is equal to hyperbolic sine x over hyperbolic cosine x. So now we just plug it in. We're just plugging and playing. Plug in and playing. E to the x minus e to the negative x over 2 over e to the x plus e to the negative x over 2. A few things that to remember here. Part 1. When you're dividing fractions, a over b over c over d is equal to a over b times d over c. An example of that would be 1/2 divided by 1/3 is equal to 1/2 times 3 over 1 is equal to 3 over 2. And if you don't believe me when I say that, look at right here. You just use the regular old school middle school style where you have 1/2 divided by 1/3. Well, you have 1/3 x is equal to 1/2. You got to solve for x. So 1/3 times what number will get you 1/2? Well, 1/3 times an unknown number is equal to 1/2. Well, you multiply both sides by 3 and you'll get x is equal to 3 over 2. And look at here, we got x is equal to 3 over 2. I know it seems a little crazy that we're in calculus and I'm describing that, but believe it or not, it confuses me and it confuses a lot of people because calculus is not hard. The hardest part of calculus is probably the algebra part. Remembering those little things that you hardly ever use. I remember them and trying to see it in a bigger, in a grand scheme of things. You know, we're used to just small numbers. Now we're dealing with not like letters, names, X's, and some numbers, and it's just crazy. So just bear with me, all right? So we know that. So what we could do is we can keep the numerator the same. So e to the x minus e to the negative x over 2. And we're going to multiply it by the reciprocal of the denominator. So the reciprocal just means that we're going to flip it in layman's terms. And what do you notice? The 2, I'll take it a step further. Let's take it a step further for those that don't see it. 2 times e to the x minus e to the negative x over 2 times e to the x plus e to the negative x. And these just cancel. So now you're left with e to the x minus e to the negative x over e to the x plus e to the negative x. And as you're proving, what I like to do is I like to go back and say, is it starting to look like what I'm trying to prove? Well, I'm I'm trying to prove that hyperbolic tan of ln x is equal to x squared minus 1 over x squared plus 1. It looks like we got the minus and the plus right here. We just haven't plugged in our x. Our x is equal to ln of x, right? If this is hyperbolic sine x, and we're saying that it's ln x is equal to ln x. So wherever x is, we're going to plug in ln x. And that's what we're going to do right now. E to the ln x minus e to the negative. And if you need to, which I always do because it's those little mistakes that will just confuse you and you won't derive the problem, the answer to your problem. So it's better to be safe than sorry and put the brackets there. So you know that it's negative ln x, right? You won't forget it. So anyways, another side note. E to the ln x is equal to x. If you don't believe me, I proved it. So, proof. Let y equal e to the ln x. Y is equal to e to the ln x. If you ln both sides, now you can bring this down just like, I haven't showed you yet, but let's say that you have 2 to the ln, and I don't know why I'm going to write it sideways so you could just start getting more confused. If you have 2l, I can't write today, ln x, you could bring this up there, and this is the same thing as ln x squared, right? So we're doing that here. If you could bring it up, similarly, you could bring it down. So we're bringing it down, so it becomes ln y is equal to ln x times ln e. And if you don't know by now, you should know, and you're going to need to know throughout your semester. So ln e is equal to 1. So if ln e is equal to 1, we're left with ln y is equal to ln x. And if you don't know, that this is something that you also need to know. If you have a function where it's ln y is equal to ln x, well, if this is equal to, and you have the ln on both sides, whatever this is should be equal to whatever this is. So we could say that y is equal to x. And what is y? Well, we already identified that we let y equal e to the ln x. So now we could plug in our y for is equal to e to the ln x, and it turns out that it's equal to x. All right, so we know that we could use that now. So let's bring up our negative exponent so that we can have, so we could make e to the ln x, because before it was e to the negative ln x. Well, we didn't prove that e to the negative ln x is equal to x. We proved that e to the ln of x. So we could even say that even ln x to the minus 1 is ln x to the minus 1 is equal to ln x minus 1, right? We could say that. We just bring it back into the brackets because there's x to the 1 to the minus 1. Well, exponent to exponent, you multiply. It becomes x to the negative 1, right? So we have it up there. Now we can use that identity. So this e to the ln of x becomes x minus e to the ln x to the minus 1 is x to the minus 1. And then we're going to do the same on the bottom. We're going to do the same on the bottom. Okay? And now it's starting to look pretty close. Let's go back. X squared minus 1 we have x minus x to the minus 1 power, x plus x to the minus 1. It's kind of looking similar, but we notice that we have negative exponent, which means that we can further simplify, right? So we're going to further simplify. If you have 1 over x, it could be written as x to the minus 1. Similarly, if you have x squared, you can write it 1 over x to the minus 2. Depends on what you want to do. Like I said, the hardest part about calculus is not calculus. It's algebra. Okay, so we're going to do that. X minus 1 over x over x plus 1 over x. Alright, we get the common denominators, and it looks like that if we get the common denominator, we'll have some x squared here, and we're going to have some 1s here. So if we get the common denominator, let's come up here. I like to do these arrows just to indicate where I'm going, right? So right here, we're going to get common denominators. So this will be x times x minus 1 over x over, and I like to exaggerate these a little bit more so that you could see clearly what fraction is dividing by what fraction. So we're going to do the same. We're going to get the common denominator for the bottom. Same thing we did over here. Fraction over a fraction. You flip the bottom fraction and then you multiply. So what happens when we flip this fraction? Well, the same thing that happens here. The 2's cancel out. So same thing, the x's cancel out because those were in the denominator. See the denominators? The denominators cancel out. And you're just left with numerator over numerator. So denominator cancel out. We're left with numerator over numerator. And we're going to simplify. X times x. Again, sometimes it can be confusing. It's not calculus. It's algebra that's confusing. That's equal to x squared minus 1 over x squared plus 1. And would you look at that? We proved it. And we can write QED because it's always kind of cool. It makes you feel good. It makes you feel like you're a true mathematician. And there you have it. If you have any questions, leave comments down below. I'm going to be going over my Calculus 2 review sheet that my professor gave us to study for the final. 1, so that I don't forget Calculus 2, and 2, because it might help you with some of the questions and the confusions that I had while I was going through it. All right, well, thank you.